This week, it's all about combinations and permutations. We'll take another look at Itertools and see how you can use it to cross-plot all the variables in your data. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to take a look at a couple more things in the Itertools tool belt, again that you may not use every day or even every week, but when you need them, they're there and waiting for you. The tools that we're going to talk about this week all focus on combinations. So let's start out by doing some imports. I'm going to import NumPy, import Itertools, and I'm going to import matplotlib.pyplot as PLT, and of course use our matplotlib inline magic. Now I'm going to generate some fake data for temperature, dew point, pressure, wind speed, gust, and wave height. So I'll go ahead and fast forward. You can do this with the same numbers that I have, or maybe some real data, or generate your own. Okay, so we've got our fake data. Now what I'm going to do is generate a dictionary where the key is the string name of that data. So for example, temperature, and the value will be that data. So this should remind you of a data structure, and what is it? Yeah, so it reminds you of a pandas data frame. I'm not using pandas here because we're not really focused on pandas. That's why I'm not using real data or NumPy, so we can focus on Itertools. But I think you can see how this could very easily be upgraded to use pandas data frames or whatever data structure you like. We've got wind speed here. Things like this could also be very useful for different model runs. You're going to change a bunch of parameters and you want to get all the combinations. All right, and finally, wave height. Okay, so the tools that I want to show you are permutations, combinations with replacement, and combinations. Then we'll add the plotting in. All right, so the first Itertool, Itertools.permutations. Data.keys, so those are our string names, so we can see what the permutations are. And then how many things we want to pick out from that. In this case, 2. Let's say we're going to do a cross plot of X and Y. Now I'm going to go ahead and put list around here so that we can see them all at once instead of having to call next, next, next. And what we see here is now we've got temperature, dew point, temperature, pressure. If we go down here though, we see we've got dew point, temperature, dew point, pressure. So these are all of the permutations with repeated combinations. And this should give you some flashbacks to statistics at different permutation and combination strategies. Okay, so let's take a look at another one. List, Itertools, and then this is going to be combinations with replacement. Notice using my tab completion there because this is a very long function name. This will be data.keys. And again, we're going to pick 2 things. Now you see we have replacement, so we pull an item out of the list randomly, or not randomly, but in a combinatoric sense now. And then we can put it back in, so we can plot temperature against temperature, let's say. Well, that's not very interesting because we know that's going to have a 1-to-1 correlation. And that maybe isn't a very useful thing to spend our time plotting. Finally, there's combinations. Itertools.combinations, data.keys, and then how many we want to pick out, 2. So in this case, this looks like what we want. Temperature versus dew point, but notice down here, no dew point versus temperature. So there are 5 temperature against, 4 dew point against, 3 pressure against, and so on. So this is what we would want because we don't really care which thing's on X or Y, we just care how correlated are they if we're plotting these. You can of course also do it in 3 dimensions and get all of the 3D combinations that you could fit planes to, let's say. So now let's go ahead and see what these loops would look like when we're doing this plotting. For xvar, yvar, in Itertools, .combinations, data.keys, 2. I'm going to create a figure and an axis, and I'm going to do that using plot.subplots. I'm going to get my xvar from data. Now you see why I put that in that data structure. Yvar for our scatter. Gonna set the label to be xvar. If you want to get fancy, you could use .title or .upper even. And now we've got, so we see, for example, temperature and dew point are 1-to-1 because that's how I designed this fake data set. The altimeter looks pretty random. Temperature and gust are correlated in a sort of an activation looking like way here. And we have a plot of everything against everything else. Now we could of course do this in 3D as well. I think that folks sometimes forget how easy it is to plot in 3D. We just have to do one more import, and that is to import the axis 3D object. Now I'm going to go up here and take our same chunk of code, paste it down here, but now we're going to have zvar as well. We're going to pull 3 things out. And I'm going to go ahead and break this up to plot.figure. Then I'm going to create my axis, and since this is a little bit of a special axis type, in my add subplot 111, I'm going to specify that the projection is 3D. You could do this in the one-line way as well, but I like to show you different ways to do these. One, because you may have a preference, or you'll see all of these in examples or other folks' code as you're reading it. Now here, our scatter call is going to stay the same, except we add zvar and set zlabel to zvar. Now we get all of these 3D plots that we could fit a plane to if we so chose to see the correlation of all of those variables. Now, just like last week, this may not be necessarily the best use case, or even your use case, certainly, of how you might use some of these things from Itertools, but they're very useful to know that they exist. Otherwise, I find you end up writing them with a series of for loops, something that's much slower, and something that's generally just going to take more of your time. So now that you're aware that these are out there, I encourage you to use them in your next project that requires combinations or permutations of your data. I hope that you found this useful, and I'll see you on next week's MetPy Monday.